Hi, so let's talk about blockchain fundamentals. The reason why we want to talk about fundamentals is to understand the inspiration behind things, how things are made up, and how things are assembled. That way, we can either use some of those inspirations for other things or use that technology to assemble that with other inspirations to make something up. Okay, so let's talk about the chain. If we look back to the early 90s, that was a great time of innovation. I mean, every week there was a new song coming out from new artists. Actually, there was multiple songs from multiple artists, brand new artists coming in of nowhere every week by week. That just indicates to you it was a great time for innovation. In looking at technology, there's a lot of innovation where a lot of concerns were being addressed. So for example, documents needed to make sure that they were consistent and reliable. So one of the ideas was that if, let's say with a timestamp, we wanted to make sure that it wasn't being tampered with. So to address that, the idea came about was to use a Merkle tree. So what is a Merkle tree? Well, a Merkle tree is basically a mechanism where you label the tree with the information contained within itself. Well, let's break down a tree to understand that. Let's just look at a tree, let's say at the trunk, the branches, and the leaves. Those leaves have some energy potential, let's say. So when we look at that energy potential, that could be represented as data. We can convert that data to a hash. And that hash would then label the branch connected to the leaf. So what is a hash? Well, a hash is just simply a format that has some systematic or consistent structure that we can handle. So that allows us to label the tree. We use a hash to label the tree. So if the leaf has some data and it has been converted to a hash and that hash has labeled the branch, then we know that that branch is associated to the leaf or tightly coupled. Let's look at the trunk of the tree. The trunk of the tree has a lot of branches closely associated with it. We can take all those branches and look at them as siblings. And each of those siblings have some hash label on it. We can take all those hash labels, combine them to create one consistent hash representation to put on the root of the tree. So this allows a Merkle tree to be able to consistently label all the data within the tree to be able to know whether or not the data has been tampered with at the leaf node or a document. These concepts we like in the tech industry because it encapsulates so many concerns. But I'm sure you probably didn't fully gauge what that really means in terms of blockchain, because how do you associate use cases to it? So let's take something else. So let's look at it another way and try to understand how a blockchain is made up as a chain. Let's look at a lineup. And let's say you wanted to buy tickets to a concert and that concert could sell out, so you wanted to wait in line the night before the booth opens. And let's say there's so many people in line, everybody's waiting to get those tickets before they sell out. Well, let's just say, just for an example, that everybody in the line could break out a line, go home, do whatever they want, and just show up the next day, and they could reformulate that line very easily. Well, there's a way. All you need to do is remember the characteristics of all the people in front of you. Actually, you only need to remember the characteristics of only one person. That only person you need to remember is the person directly in front of you. And if everybody remembers only that person in front of them, then when you reform the line the next day, everybody can easily reformulate in the line. They just have to associate by looking for that person in front of them. Now, let's just say the next day we have opening booth and tickets are being sold and there's no line and nobody actually formed a line. There's nothing to formulate. Let's just say everybody shows up at the same time. How do you formulate that line? Well, it's very challenging, and this is where mining comes into play. So mining is a way where you can slow things down so that you can have a proper sequence of the chain. You don't want to blow out the chain right away and just create every node in the chain just instantaneously. You need some time to address some concerns so that you can properly sequence this chain. Mining has had a bad rep because it is assumed to have heavy computations. It's not very good for the environment. Well, if you look at the entire industry, everything in the tech industry is all client server, and is highly dependent on cloud infrastructure. These cloud infrastructures have all kinds of data centers associated with it. I mean, where we are at Contemplate, we're coming up with solutions that are not dependent on the client server. For example, Synapse Chain is not dependent on the client server. So we're trying to be green by not depending on the client server, but looking at other ways to do the same thing. Let's talk about the inspiration for mining in the current trend of blockchain. Let's look at mining where it came from. It came from Hashcash. That's again from the early 90s. Actually, it was 1997. Back then, a lot of spam emails were going out, and a way to slow down these spam emails was to force the sender to deal with some challenge or some computation, and if they are able to deal with that computation, that would prove who they are, and so then the email could go through. Now, obviously, somebody sending out spam email does not want to spend time dealing with any CPU computation, because the whole point of spam email is to save cost by spamming your email. And also with spam attacks as well, other spam attacks, like cybersecurity related spam attacks. So Hashcash was a way to deal with this to mitigate the spam email. This was an inspiration for blockchain, and the same methodology, not that same direct technology, but that same methodology was used in blockchain in mining. So it does help validate, the signer, but mining in blockchain requires no signer. It could be used as a consensus. It could be used to slow down the process to properly create the chain or sequence the chain. So these fundamentals, they're very simple fundamentals. And with the inspiration, you can see how that has been modeled the way it has. And we know that there's going to be some more changes and it's going to mature. And it's just so interesting. Well, as the maturity occurs, where's all that inspiration coming from? What are all those concerns being addressed? And how are they being addressed? So if we look at synapsechain.com, let's look at this in terms of how it could be used in a blockchain. Why is cryptocurrency a big deal in blockchain? Well, cryptocurrency just so happens to be one of the motivators to create blockchain. It is an exchange. It is not a monetary system, but rather an exchange. If we look at money in isolation, money is just an abyss. It's a void. All that money does in isolation is allow people to dream or to realize how to address their needs. As they accumulate money, they are actually focused on dealing with the heavier challenges of needs that are more complicated. Now, the reason why I say that it's a void or it's an abyss in isolation is because if you focus only on money, then you're actually neglecting your needs, because you've developed this other need of accumulating cash. So there's a balance. You can't look too far ahead of only looking at accumulating cash and not addressing your needs. You need to address your needs while also in parallel accumulating cash. So that's why it could be seen in isolation as a void. The idea with cryptocurrency and blockchain is it allows there to be an exchange, so you can convert that accumulation into some potential so that you can actually address some needs. Now, mind you, all of this is still emerging where we're at some point going to have a wisdom system. A wisdom system is something where we don't really need money anymore. There could be in the future, for example, a time where money is not needed. Because if we have a sophisticated system that can help us prioritize our needs and help us address our needs, then what is the need for money? But for now, we're looking at what we have implemented. This is the only way to make sense of the world. So we're looking at blockchain for what it is today, fundamentally. So if we look at Synapse Chain and we compare that to, let's say, a cryptocurrency, what is consistent amongst all those phenomena? Well, we can represent them as blocks, and then those blocks can be simply hashed. If we look at Synapse Chain, it's been designed to be encapsulated as a block. We can take this entire experience and all the data that's populating this experience, we can represent that into a block, and that can be in the chain. How is that a use case for us? Well, an individual can create a store, an e-commerce store, and create an e-commerce experience and sell goods and services using one block of the chain. Likewise, an organization can use Synapse Chain to represent an e-commerce store and the data behind it, and it can version it and it could create workflow out of it. That could be several blocks in a chain that could be either sequenced or like a tree in parallel. We're looking at blockchain and we're looking at the fundamentals thereof to see the potential of how we could use blockchain not only for cryptocurrency, but also other alternatives of function and capability to drive us closer to the future. I hope you enjoyed the video. We'll have some more videos coming out. For now, enjoy the day. Thank you.